Up till now, we've been talking about wave speed. And now I want to distinguish because there is another velocity that is going to appear and that occasionally we want to think about. So it can be very confusing because we're trying to distinguish between two things that are speeds but are very different. So I'm going to be talking about a transverse wave for this, just for simplicity. This still exists for a longitudinal wave, but I want to just be able to really clarify what I mean. So here, instead of wave speed, we want to think about the velocity of the medium itself. So wave speed was the rate at which the peak was moving sideways. So this is the motion of the disturbance. Velocity of the medium is the rate at which the medium is going up and down, right? So again, specific to a transverse wave. So this is like thinking about a boat on the ocean, that waves are going to be passing by the boat, but the boat can be quote unquote being still. The boat's going to bob up and down. That relates to the velocity of the motion, but it looks like the waves are going sideways past the boat. The water itself is just moving up and down as well. So remember that the disturbance is different than the medium, and so the disturbance can have a different speed than the medium. So let's look at a picture. So we have this sinusoidal function, and this is, for instance, we can think about this as a string if you want, but it can be anything. If the wave is going to the right, that means in the next moment, my peak needs to be farther over. And my drawing is failing me. So what that looks like is that these need to go up, and these points need to go down, so that in the next moment, it looks like the peak has moved to the right. So when we're talking about velocity of the medium, we're talking about these green arrows. So notice that the velocity of the wave is constant. This is one value and it's not changing in time. It doesn't depend on position. These actually are going to be a function of position and time themselves, because you have different wave speeds at different positions. And if we think about velocity, here it's down, here it's up, here it's zero. But then at a later point in time, this spot is going to be moving with a different velocity, if again we mean the medium going up and down. So the wave speed is constant. The velocity of the medium is a function itself. How we get this is we think about displacement, right? So vertical here is our displacement, and we have that nice function here. Well, to get the velocity where it's of the medium, not the wave speed, we just take the derivative with respect to time. And so sine becomes negative cosine, or sorry, sine becomes cosine, and we take the derivative with respect to time, so we only need to think about this part, and so negative omega comes out here. And so we're left with the exact same argument on the inside, but a cosine. So that's really just, you can think of that as a phase shift, but now you have a different coefficient out front. So what that means is the maximum speed you have, again, not wave speed, but velocity of the medium, is given by the angular frequency of your wave times the amplitude. So this does depend on the amplitude of the displacement, which otherwise has just been hanging out front independent of everything else. So this corresponds, for instance, to what you see there, or what you see there, your maximum values. How do I know that that's maximum? Well, going from sine to cosine, I know that wherever I had a 0 for sine is in fact my maximum value for so 0 for sine is maximum for cosine. So whatever your positions were at equilibrium are the ones moving the fastest. You can also think about this a little bit like a pendulum, that the fastest motion of the pendulum is when it's actually passing back through the equilibrium point. So you have a similar phenomena here. So again, your big takeaway here is that there are two speeds or velocities we could be talking about. The velocity of the wave is a constant, thinking about the peak. Where is the peak? And the velocity of the medium is this up-down motion. So again, I keep saying up-down. This does exist for longitudinal waves as well, but then it gets really complicated to think about, so we'll focus here on transverse.